I think people talk about AGI and they're always just talking about the private AI labs. People are just vastly underrating the chances of this more or less looking like a government project. I mean, look, when we have like literal superintelligence on our cluster, and it's like you have a billion superintelligent scientists that they can like hack everything, they can like Stuxnet the Chinese data centers. Do you really think that'll be like a private company? There's this sort of misconception that AGI development is going to be some like beautiful decentralized thing. That's not how it's going to look like. $100 billion, $1 trillion cluster, it's not going to be that many people that have it. It's going to be 2 or 3 big players on the private world. You're talking about basically the most powerful weapon ever, and you're kind of making this radical bet on like a private company CEO as the benevolent dictator. I mean, what do we do with nukes? The way we keep nukes in check is not like, a beefed up Second Amendment where like each state has their own like little nuclear arsenal and like, Dario and Sam have their own little nuclear arsenal. No, it's institutions, it's constitutions, it's laws. The other issue though, it won't just be 2 or 3. There'll be 2 or 3 and it'll be China and Russia and North Korea. In the private lab world, there's no way they'll have security that is good enough.
What better way to understand the danger of AI than hearing it directly from the people who built it? Leopold Aschenbrenner wasn't a YouTuber. He wasn't a critic. He was on the inside at OpenAI, working on alignment, safety, and preparing for the moment machines become smarter than humans. And then he was fired, reportedly for leaking internal documents, not just opinions, not just speculation, but actual insight into what's coming, and how soon. After he left, Leopold published a document called Situational Awareness. It lays out a detailed roadmap, backed by data, showing exactly how AI is likely to evolve over the next few years. And if even half of what he predicts turns out to be true, we're looking at a world-changing shift that most people aren't ready for. He says superintelligence, AI that's smarter than the best researchers, could arrive as early as 2027. That's not a guess. That's based on scaling trends we've already seen from GPT-2 to GPT-4. And what's coming next?
So, I think sort of 25, 26, we're going to get models that are, basically smarter than most college graduates. I think sort of a lot of the economic usefulness, I think, really depends on sort of unhobbling. Basically, it's, the models are kind of, they're smart, but they're limited, right? There's this chatbot, and things like being able to use a computer, things like being able to do kind of like agentic long horizon tasks.
Yeah.
And then I think by 27, 28, if you extrapolate the trends and we'll talk about that more later, and I talk about it in the series, I think we hit, basically, like as smart as the smartest experts. I think the unhobbling trajectory kind of points to, it looks much more like an agent than a chatbot. And much more almost like basically like a drop-in remote worker, right? So it's not like, I think this is the sort of question on the economic returns. I think a lot of the intermediate AI systems could be really useful, but it actually just takes a lot of schlep to integrate them, right? Like GPT-4, whatever, 4.5, probably there's a lot you could do with them in a business use case, but you really got to change your workflows to make them useful. And it's just like, there's a lot of, it's a very Tyler Cowen-esque take. It just takes a long time to diffuse,
Yeah.
It's like, we're an SF and so we missed that or whatever. But I think in some sense, the way a lot of these systems won't be integrated is you kind of get this sort of sonic boom where it's, the sort of intermediate systems could have done it, but it would have taken schlep. And before you do the schlep to integrate them, you get much more powerful systems that are sort of unhobbled. And so they're this agent and there's this drop-in remote worker. And, and then you're kind of interacting with them like a coworker, right? You can do Zoom calls with them and you're slacking them and you're like, can you do this project? And then they go off and they, go away for a week and write a first draft and get feedback on them and, run tests on their code. And then they come back and then you see it and you tell them a little bit more things or, and that'll be much easier to integrate. And so, it might be that actually you need a bit of overkill to make the sort of transition easy and to really harvest the gains.
What do you mean by the overkill? Overkill on the model capabilities?
Yeah. So basically the intermediate models could do it, but it would take a lot of schlep. So then, they're like, actually it's just the drop-in remote worker kind of AGI that can automate, cognitive tasks that actually just ends up kind of like, basically it's you're like, the intermediate models would have made the software engineer more productive, but, will the software engineer adopt it? And then the, 27 model is, you just don't need the software engineer. You can literally interact with it like a software engineer and it'll do the work of a software engineer.
All right, let's get into the first warning. And in my opinion, this one alone should be enough to stop people in their tracks. Leopold Aschenbrenner, a former OpenAI researcher, says this: "It is strikingly plausible that by 2027, models will be able to do the work of an AI researcher or software engineer." And to be clear, he's not saying that in some fantasy future where AI has a face and walks around like a robot. No, he's talking about the models we already have today, just scaled further.
And this is where, the sort of intelligence explosion stuff comes in, which, we should also talk about later. It's sort of like, you have AGI, you have this sort of drop-in remote worker that can replace, you or me, at least that sort of remote jobs, cognitive jobs. And then, I think fairly quickly, by default, you turn the crank, one or two more times, and then you get a thing that's smarter than humans. But I think even more than just turning the crank a few more times, I think one of the first jobs to be automated is going to be that of sort of an AI researcher engineer. And if you can automate AI research, I think things can start going very fast. Right now there's already this trend of, half an order of magnitude a year of algorithmic progress. Suppose, at this point, you're going to have GPU fleets in the tens of millions for inference, or more. And, you're going to be able to run like 100 million human equivalents of these sort of automated AI researchers. And if you can do that, you can maybe do, a decade's worth of sort of ML research progress in a year. You get some sort of 10x speed up. And if you can do that, I think you can make the jump to kind of like AI that is vastly smarter than humans, within a year, couple years. And then, that broadens, right? So you have this sort of initial acceleration of AI research that broadens to like you apply R&D to a bunch of other fields of technology. The sort of like extremes, at this point you have like a billion just super intelligent researchers, engineers, technicians, everything, superbly competent at all the things, they're going to figure out robotics, right? We talked about it being a software problem. Well, now you have a billion of super smarter than the smartest human researchers, AI researchers on your cluster, at some point during the intelligence explosion, they're going to be able to figure out robotics, and then again, that expands. And, I think if you play this picture forward, I think it is fairly unlike any other technology in that it will, I think, a couple years of lead could be utterly decisive in, say, like military competition.
One thing I'm uncertain about is whether it's more like what you say, where it's more of an implosion of you have developed an AGI and then you make it into an AI researcher. And for a while, a year or something, you're only using this ability to make hundreds of millions of other AI researchers. And then like the thing that comes out of this really frenetic process is a super intelligence, and then that goes out in the world and is developing robotics and helping you take over other countries and whatever.
I think it's a little bit more, it's a little bit more kind of like, it's not like, on and off. It's a little bit more gradual, but it's sort of like, it's an explosion that starts narrowly. It can do cognitive jobs. The highest ROI used for cognitive jobs is make the AI better, like solve then you solve robotics, now you can do R&D and, like biology and other technology. Initially you start with the factory workers, they're wearing the glasses and the AirPods, and the AI is instructing them, right? Because you kind of make any worker into a skilled technician, and then you have the robots come in, and anyway, so it sort of expands. This process expands.
Meta's Ray-Bans are compliment to their llama.
Well, it's like whatever, like the fabs in the US, the constrained to skilled workers, right?
Sure.
You have the, even if you don't have robots yet, you have the cognitive superintelligence, and it can kind of make them all into skilled workers immediately. But that's it's a very brief period. Robots will come soon.
Sure. Okay. So suppose this is actually how the tech progresses. In the United States, maybe because these companies are already experiencing hundreds of billions of dollars of AI revenue.
And at this point, companies are borrowing, hundreds of billions or more in the corporate debt markets,
But why is a CCP bureaucrat, some 60-year-old guy, he looks at this and he's like, oh, it's like Copilot has gotten better now. Why are they now?
I mean, this is much more than Copilot has gotten better now. I mean, at this point,
to them, so because to shift the production of an entire country to dislocate energy that is otherwise being used for consumer goods or something, and to make it that all feed into the data centers. What will that be obvious? Because part of this whole story is you realize the super intelligence is coming soon, right? And I guess you realize it. Maybe I realize it. I'm not sure how much I realize it. But will the national security apparatus in the United States and will the CCP realize it?
Yeah, I mean, look, I think in some sense this is a really key question. I think we have sort of a few more years of mid-game, basically, and where you have a few more 2023s, and that just starts updating more and more people. And, I think, the trend lines, will become clear. I think you will see some amount of the sort of COVID dynamic, right? Like COVID was like, February of 2020, it's like, honestly feels a lot like today, where it's like, it feels like this utterly crazy thing is impending, is coming. You kind of see the exponential, and yet most of the world just doesn't realize, right? The mayor of New York is like, go out to the shows, and this is just, like Asian racism or whatever, but, at some point the exponential, like, at some point people saw it, and then, like just kind of crazy radical reactions came.
Then he adds, that doesn't require believing in science fiction. It just requires believing in straight lines on a graph. And honestly, he's right. Just look at what's already happened. GPT-2 was basically a sentence guesser. GPT-3 shocked people with how articulate it was. GPT-4 can pass professional exams, write code, tutor you in calculus, and beat most students in college-level writing. Each of those leaps happened in under 4 years. Now do the math. If the jump from GPT-2 to GPT-4 is what we got from simply scaling compute and training, then by 2027, with the same trend, we're looking at a system that doesn't just assist human researchers, it replaces them. Leopold even compares the next leap, from GPT-4 to AGI, as another preschooler to high schooler jump. That's how fast we're moving. So if that pattern holds, we'll soon have models that outperform top-tier researchers in almost every field that doesn't require physical labor. And that's not speculation. We're already seeing GPT-4 outperform humans on standardized tests, bar exams, SATs, advanced math. These models are scoring in the 90th percentile or higher. But somehow, most people still think this tech is years away from being a real threat. That's the terrifying part. And now, there's talk of GPT-5 being able to perform digital tasks autonomously. Go to a website, grab information, complete online chores like a virtual assistant that doesn't just answer, it acts. We're talking about a model that could browse, reason, and execute tasks on its own. Not just giving you information, but doing the job for you. Leopold says, barely anyone is pricing this in. And he's right again. Most people are still reacting like this is just a cool demo. But the people building these systems? They know what's coming. They know we're racing toward a future where machines aren't just tools, they're decision makers. And most of society, still asleep at the wheel.
Superintelligence applied to sort of broad fields of R&D, and then, the sort of industrial explosion as well. You have the robots, you're just making lots of material. I think that could compress, basically compress kind of like a century worth of technological progress into less than a decade. And that means that, a couple years could mean a sort of Gulf War I style, advantage in military affairs. Including a decisive advantage that even preempts nukes, right? Suppose how do you find the stealthy nuclear submarines? Right now, that's a problem of you have sensors, you have the software to detect where they are. You can do that, you can find them. You have kind of millions or billions of mosquito-like sized drones, and they take out the nuclear submarines, they take out the mobile launchers, they take out the other nukes. And anyway, so I think enormously destabilizing, enormously important for national power. And at some point, I think people are going to realize that. Not yet, but they will. And when they will, I think there will be sort of, I don't think it'll just be the sort of AI researchers in charge.
Now here's where things take a turn. And it's honestly one of the most disturbing parts of the whole document. Once AI becomes good enough to automate AI research, it triggers something called a recursive feedback loop. Leo describes it like this. If these AI systems could automate AI research itself, that would set intense feedback loops. What does that mean? Basically, AI builds better AI. Then that AI builds even better AI, and the cycle repeats. At first, maybe it's just speeding things up a little, but then it gets out of control fast. Leopold explains this in phases. First, you get a system that speeds up human researchers. Maybe it's 1.5x faster. Then it reaches 3x, then 10x. Then 100x. Eventually, we're talking about millions of copies of an AI researcher running 24/7, never sleeping, never making mistakes, and getting smarter every day. He says, we don't need to automate everything, just AI research. That line is chilling, because it means we don't need robots or sci-fi level general intelligence to break the world open. We just need to replace the research process. And everything else follows. Let's put this into context. Imagine a world where 100 million digital researchers are working at 100 times human speed. That's the equivalent of 10 billion researcher hours every single hour. Imagine the kind of breakthroughs you could get from that. And this isn't just speculation. We've already seen it start to happen. AlphaGo discovered moves in Go that no human had ever considered. GPT-4 is already writing research summaries, planning code architecture, and even proposing experiments. Now imagine that same model trained specifically to improve itself, and then scaled up across hundreds of millions of instances. Leo writes, AI research compressed into weeks. Centuries of innovation, done in a single quarter. That's not just disruptive. That's a civilizational level change. It collapses the entire R&D cycle. There's no time for regulation, no time for ethics debates, and certainly no time to prepare. So if you're wondering why this matters, because once this loop starts, humans are no longer in charge of the pace of progress. And if the first thing this new intelligence decides to do is make itself smarter, then it's already too late to stop what comes next.
The possibilities for dictatorship with superintelligence are sort of even crazier, right? I think, imagine you have a perfectly loyal military and security force, right? That's it. No more rebellions, right? No more popular uprisings, perfectly loyal, you have perfect lie detection, you have a surveillance of everybody, you can perfectly figure out who's the dissenter, weed them out, no Gorbachev would have ever risen to power who had some doubts about the system, no military coup would have ever happened. And I think I think there's a real way in which, part of why things have worked out is that, ideas can evolve, and, there's sort of like some sense in which sort of time heals a lot of wounds, and time, and solves, a lot of debates, and a lot of people had really strong convictions, but, a lot of those have been overturned by time because there's been this continued pluralism and evolution. I think there's a way in which kind of like, if you take a CCP-like approach to kind of like truth is what the party says, and you supercharge that with superintelligence, I think there's a way in which that could just be like locked in and enshrined for a long time, and I think the possibilities are pretty terrifying.
So I wonder, when we're talking today about the CCP, listen, the people in China who will be doing their version of the project will be AI researchers who are somewhat westernized, who interact with, either got educated in the West or have colleagues in the West. Are they going to sign up for the CCP project that's going to hand over control to Xi Jinping? What's your sense on? I mean, it's just like fundamentally they're just people, right? Like, can't you like convince them about the dangers of superintelligence?
Will they be in charge though? I mean, in some sense, this is also the case, in the US or whatever. Right. There's this sort of like rapidly depreciating influence of the lab employees. Like right now, the sort of AI lab employees have so much power, right? Over this, like you
but
saw
they're going to get automated, and then
you saw this in the November event, so much power, right? But both they're going to get automated, and they're going to lose all their power, and it'll just be kind of like a few people in charge with their sort of armies of automated eyes. But also, it's sort of like the politicians and the generals and the sort of national security state. A lot of, there's sort of, this is the sort of some of these classic scenes from the Oppenheimer movies. The scientists built it, and then it was kind of, and the bomb was shipped away and it was out of their hands. I actually think it's good for like lab employees to be aware of this. It's like, you have a lot of power now, but maybe not for that long, and use it wisely. I do think they would benefit from some more organs of representative democracy.
What do you mean by that?
Oh, I mean, in the sort of in the OpenAI board events, employee power is exercised in a very sort of direct democracy way, and I feel like that's how some of how that went about. I think really highlighted the benefits of representative democracy and having some deliberative organs.
Interesting.
Yeah.
Let's go back to the 100 billion revenue, whatever. And so these companies,
$1 trillion cluster.
Yeah, the companies are trying to build clusters that are this big.
Yeah.
Where are they building it? Because if you say it's the amount of energy that would be required for a small or medium-sized U.S. state, is it then Colorado gets no power and it's happening in the United States, or is it happening somewhere else?
Oh, I mean, in some sense, this is the thing that I always find funny is, you talk about Colorado gets no power. The easy way to get the power would be like, displace less economically useful stuff. It's like, whatever, buy up the aluminum smelting plant, and, that has a gigawatt, and, we're going to replace it with the data center because that's important. That's not actually happening because a lot of these power contracts are really sort of long-term locked in. There's obviously people don't like things like this. And so it seems like in practice, what it's requiring, at least right now, is building new power. That might change. And I think that's when things get really interesting, when it's like, no, we're just dedicating all of the power to the AGI. But anyway, so right now it's building new power. 10 gigawatt, I think quite doable. It's like a few percent of like US natural gas production. When you have the 10 gigawatt training cluster, you have a lot more inference. So that starts getting more, I think 100 gigawatt, that starts getting pretty wild. That's, again, it's like over 20% of US electricity production. I think it's pretty doable, especially if you're willing to go for like natural gas. I do think it is incredibly important that these clusters are in the United States.
And why does it matter it's in the US?
Look, I think there's some people who are, trying to build clusters elsewhere. And, there's like a lot of free flowing Middle Eastern money that's trying to build clusters elsewhere. I think this comes back to the sort of like national security question we talked about earlier. Like, would you do the Manhattan Project in the UAE, right? And I think basically like putting the clusters, I think you can put them in the US, you can put them in sort of like allied democracies. But I think once you put them in kind of like, dictatorships, authoritarian dictatorships, you kind of create this, irreversible security risk, right? So, one, cluster is there, much easier for them to exfiltrate the weights. They can like literally steal the AGI, the superintelligence. It's like they got a copy of the, of the atomic bomb, and they just got a direct replica of that. And it makes it much easier to them. They have weird ties to China. You can ship that to China. So that's a huge risk. Another thing is they can just seize the compute, right? Like maybe right now they just think of this. In general, I think people, I think the issue here is people are thinking of this as like, ChatGPT, big tech product clusters. But I think the clusters being planned now, 3 to 5 years out, like, may well be the like AGI superintelligence clusters. And so anyway, so like when things get hot, they might just seize the compute. And I don't know, suppose we put like, 25% of the compute capacity in these sort of Middle Eastern dictatorships. Well, they seize that. And now it's sort of a ratio of compute of 3 to 1. And, we still have some more, but even only 25% of compute there, like, I think it starts getting pretty hairy. I think 3 to 1 is like not that great of a ratio. You can do a lot with that amount of compute. And then look, even if they don't actually do this, right? Even if they don't actually seize the compute, even if they actually don't steal the weights, there's just a lot of implicit leverage you get, right? They get the seat at the AGI table. I don't know why we're giving authoritarian dictatorships the seat at the AGI table.
This is where the stakes go from scary to existential. Leo argues that superintelligence isn't just powerful, it's political. Whoever builds it first wins. Not just the AI race, but the entire global power structure. He puts it bluntly. Superintelligence could eliminate every historical threat to a dictator's rule. Let that sink in. Historically, authoritarian regimes had limits: rebellion, civil unrest, lack of innovation. But if a dictator gets access to AGI-level tech, those limits disappear. He paints a very real possibility. AI-controlled surveillance systems watching every citizen 24/7. Robotic police with zero dissent and perfect obedience. AI models capable of detecting lies, suppressing protests, predicting disloyalty before it happens. That's not just dystopia, that's permanent authoritarianism. And the terrifying thing? We're not securing this technology. Leo warns that top AI labs today, yes, even OpenAI, are treating AGI-level tech like a university research project. He literally says, they are handing the key secrets for AGI to the CCP on a silver platter. Why? Because most companies don't have real security infrastructure, no classified clearance process, no military-level information control, and get this, Leopold claims secrets are being leaked through open laptops at cafes, screenshots, conversations at parties. If true, that's insane. We're talking about a $1 trillion race with global consequences, and the secrets are sitting on someone's MacBook Pro next to their coffee. OpenAI even responded indirectly to this, releasing a blog post titled "Securing Research Infrastructure for Advanced AI." But let's be honest, why was a blog post even necessary if the system was secure to begin with? Leopold raises the most critical red flag. Even if the US builds superintelligence first, if it gets leaked to a hostile state, it's over. Here's the analogy he uses. Imagine if the Nazis had gotten an exact duplicate of every atomic bomb made in Los Alamos. Now apply that to AGI, the code, the weights, the training pipeline. You don't need to recreate the science, you just need to copy the folder. That's what model weights are, files. Not locked down physical tech, not buried infrastructure, just files. Ones that can be stolen, duplicated, and scaled. If China, or any other adversary, gets access to that, they can unleash their own intelligence explosion. And at that point, there's no time to catch up, no buffer, no pause button. Leo says, "Our failure today will be irreversible." And I believe him. Because once another power, authoritarian or otherwise, has AGI, they don't need permission. They don't need to tell us. They can scale it silently, improve it internally. And once the intelligence explosion begins, they've already won. So to sum up, superintelligence isn't just about automation. It's about power. If the US leaks its AGI secrets, there's no recovery. And if the wrong regime controls AGI first, it's not just political dominance, it's permanent global control. And somehow, we're not treating it like the Manhattan Project. We're treating it like startup software. That's the real danger. So what do you think? Is anyone really ready for this? If this video made you think, hit like, subscribe, and let me know your thoughts in the comments. We're just getting started. Elon Musk's XAI might be ready to disrupt the market, and Nvidia is right in the crosshairs. While many are still focused on Nvidia's monumental growth, Jensen Huang is sounding the alarm about the next big shakeup. So, what's really at stake for Nvidia? And why does Huang believe that Musk's latest AI venture could leave the competition in the dust?
I'm Julie Hyman, host of Yahoo Finance's Market Domination, here with our tech editor, Dan Howley. NVIDIA has done it again, the chip giant blowing past analyst expectations in its strong fiscal first quarter. Data center revenue alone soaring by 427% year over year. And the company also gave another bullish sales forecast, which shows that AI spending momentum continues apace. On top of all that, the company also announced a 10-for-1 forward stock split and raised its dividend. Joining us now, NVIDIA founder and CEO Jensen Huang, fresh off the conference call. Jensen, welcome. Thank you so much for being with us.
I'm happy to be here. Nice to see you guys.
You too. I want to start with Blackwell, which is your next generation chip. It's shipping this year, you said on the call. You also said on the call, we will see a lot of Blackwell revenue this year. So if we're looking at about $28 billion in revenue in the current quarter, and Blackwell is a more expensive product than Hopper, the chip series out now, what does that imply about revenue in the fourth quarter and for the full year?
Well, it should be significant. Yeah, Blackwell, and as you know, we guide one quarter at a time. And but what I could tell you about Blackwell is this. This is a giant leap in AI, and it was designed for trillion parameter AI models. And this is, as you know, we're already at 2 trillion parameters. Model sizes are growing, about doubling every 6 months, and the amount of processing between the size of the model, the amount of data is growing 4 times. And so the ability for these data centers to keep up with these large models really depends on the technology that we bring to them. And so the Blackwell is designed also for incredibly fast inferencing. And inference used to be about recognition of things, but now inferencing, as you know, is about generation of information, generative AI. And so whenever you're talking to ChatGPT and it's generating information for you or drawing a picture for you or recognizing something and then drawing something for you, that generation is a brand new inferencing technology, is really, really complicated and requires a lot of performance. And so Blackwell is designed for large models, for generative AI, and we designed it to fit into any data center. And so it's air-cooled, liquid-cooled, x86, or this new revolutionary processor we designed called Grace Blackwell Superchip. And then, supports InfiniBand data centers like we used to, but we also now support a brand new type of data center, Ethernet. We're going to bring AI to Ethernet data centers. So the number of ways that you could deploy Blackwell is way, way higher than Hopper generation. So I'm excited about that.
I want to talk about the inferencing, Jensen. You know, some analysts have brought up the idea that as we move over towards inferencing from the training, that there may be some in-house companies, processors from companies, those made from Microsoft, Google, Amazon, may be more suited for the actual inferencing. I guess, how does that impact NVIDIA then?
Well, inferencing used to be easy. You know, when people started talking about inference, generative AI didn't exist. And now generative AI is of course, is about prediction, but it's about prediction of the next token or prediction of the next pixel or prediction of the next frame. And all of that is complicated. And generative AI is also used for understanding in order to generate the content properly, you have to understand the context and what is called memory. And so now the memory size is incredibly large, and you have to have context memory. You have to be able to generate the next token really, really fast. It takes a whole lot of tokens to make an image. It takes a ton of tokens to make a video, and it takes a lot of tokens to be able to reason about a particular task so that it can make a plan. And so the generative AI era really made inference a million times more complicated. And as you know, the number of chips that were intended for inference kind of fell by the wayside, and now people are talking about building new chips. You know, the versatility of NVIDIA's architecture makes it possible for people to continue to innovate and create these amazing new AIs. And then now Blackwell's coming.
Jensen Huang's message couldn't be clearer. AI is not just the future, it's the now. NVIDIA's explosive growth, particularly in the data center sector, speaks volumes about the accelerating demand for AI. But let's dig deeper here. The numbers alone are staggering. 427% growth in data center revenue. AI spending shows no sign of slowing down. And the company is even rewarding investors with a 10-for-1 stock split. This is a signal that AI is in the middle of a seismic shift, and NVIDIA is at the heart of it. When Huang talks about Blackwell, the upcoming chip that's poised to disrupt the AI space, he's talking about the foundation for the next era of AI. Blackwell is designed to handle the mammoth size of AI models that are doubling in size every 6 months. These are trillion-parameter powerhouses that require an entirely new level of infrastructure to run effectively. But here's the thing. This is NVIDIA rethinking the very structure of AI processing. Blackwell's design focuses not just on scaling performance, but on supporting generative AI. If you've been paying attention, you know that generative AI is changing everything. How we interact with machines, how content is created, and even how industries will operate.
So in other words, you think you still have a competitive advantage even as the market sort of shifts to inferencing?
We have a great position in inference because inference is just a really complicated problem. You know, and the software stack is complicated. The type of models that people use is complicated. There's so many different types. It's just going to be a giant market opportunity for us. The vast majority of the world's inferencing today, as people are experiencing in their data centers and on the web, vast majority of the inferencing today is done on NVIDIA. And so I expect that to continue.
You said on the call a couple of times that you'll be supply constrained for both Hopper and then Blackwell chips well until next year because of the vast demand that's out there. What can you do about that? Are there any sort of levers you can pull to help increase supply?
Hopper demand grew throughout this quarter after we announced Blackwell. And so that kind of tells you how much demand there is out there. People want to deploy these data centers right now. They want to put our GPUs to work right now and start making money and start saving money. And so that demand is just so strong. You know, it's really important to take a step back and realize that what we build is not a GPU chip. We call it Blackwell and we call it GPU, but we're really building AI factories. These AI factories have CPUs and GPUs and really complicated memory. The systems are really complicated. It's connected by NVLink. There's an NVLink switch. There's InfiniBand switches, InfiniBand NICs, and then now we have Ethernet switches and Ethernet NICs. And all of this connected together with this incredibly complicated spine called NVLink. And then the amount of software that it takes to build all this and run all this is incredible. And so these AI factories are essentially what we build. We build it as a holistic unit, as a holistic architecture and platform, but then we disaggregate it so that our partners could take it and put it into data centers of any kind. And every single cloud has slightly different architectures and different stacks, and our stacks and our architecture can now deeply integrate into theirs, but everybody's a little different. So we build it as an AI factory. We then disaggregate it so that everybody can have AI factories. This is just an incredible thing, and we do this at very high volume. It's just very, very hard to do. And so every component, every part of our data center is the most complex computer the world's ever made. And so it's sensible that almost everything is constrained.
Jensen, I want to ask about the cloud providers versus the other industries that you said are getting into the generative AI game or getting NVIDIA chips. You had mentioned that in comments in the actual release, and then we heard from CFO Colette Kress that 40%, mid 40% of data center revenue comes from those cloud providers.
As we transition from AI training to AI inferencing, we're seeing a major shift in the technology landscape. For those unfamiliar with the term, inferencing is where AI systems make predictions based on data, whether it's generating the next word in a sentence, the next pixel in an image, or even the next frame in a video. This is where things start to get incredibly complex. And yet, Jensen Huang's confidence in NVIDIA's position remains unshaken. For NVIDIA, inferencing used to be a secondary concern. Training AI models was the real challenge. But now, with the rise of generative AI, inferencing is front and center. It's no longer enough to just process data quickly. You need to understand it, adapt to it, and generate something new from it. And this is where NVIDIA shines. While other tech giants like Google and Amazon are working on their own inferencing chips, NVIDIA's versatile architecture allows it to maintain its lead. In fact, Huang is clear that NVIDIA's GPUs are already at the forefront of this space, running the vast majority of inferencing workloads across data centers and the web. The real significance here is that inferencing is now intertwined with generative AI, making it much more complicated than ever before.
Elon talking about the incredible infrastructure that he's building. And one of the things that's really revolutionary about the version 12 of Tesla's full self-driving is that it's an end-to-end generative model, and it learns from watching videos, surround video, and it learns about how to drive end-to-end and using generative AI. Predict the path and the how to steer how to understand and how to steer the car. And so the technology is really revolutionary, and the work that they're doing is incredible. So I gave you two examples. A startup company that we work with called Recursion has built up a supercomputer for generating molecules, understanding proteins and generating molecules for drug discovery. The list goes on. I mean, we can go on all afternoon, and just so many different areas of people who are now recognizing that we now have software and AI model that can understand and learn almost any language. The language of English, of course, but the language of images and video and chemicals and protein and even physics, and to be able to generate almost anything. And so it's basically like machine translation. And that capability is now being deployed at scale in so many different industries.
Jensen, just one more quick last question. I'm glad you talked about the auto business and what you're seeing there. You mentioned that automotive is now the largest vertical, enterprise vertical within data center. You talked about the Tesla business, but what is that all about? Is it self-driving among other automakers too? Are there other functions that automakers are using within data center? Help us understand that a little bit better.
Well, Tesla is far ahead in self-driving cars, but every single car someday will have to have autonomous capability. It's safer, it's more convenient, it's more fun to drive, and in order to do that, it is now very well known, very well understood, that learning from video directly is the most effective way to train these models. We used to train based on images that are labeled. We would say, this is a car, this is a car, this is a sign, this is a road, and we would label that manually. It's incredible. And now we just put video right into the car and let the car figure it out by itself. And this technology is very similar to the technology of large language models, but it requires just an enormous training facility. And the reason for that is because the data rate of video, the amount of data of video is so high. Well, the same approach that's used for learning physics, the physical world, from videos that is used for self-driving cars is essentially the same AI technology used for grounding large language models to understand the world of physics. So technologies that are like Sora, which is just incredible, and other technologies, VO from Google, incredible. the ability to generate video that makes sense, that are conditioned by human prompt, that needs to learn from video. And so the next generation of AIs need to be grounded in physical AI, needs to understand the physical world. And the best way to teach these AIs how the physical world behaves is through video, just watching tons and tons and tons of video. And so the combination of this multimodality training capability is going to really require a lot of computing demand in the years to come.
Jensen, as always, super cool stuff and great to be able to talk to you. Dan and I really appreciate it. Jensen Huang, everybody, founder and CEO of NVIDIA.
Great to see you guys. Thank you.
The competition is heating up, but NVIDIA isn't just sitting back. Huang highlights the company's ability to adapt, innovate, and create a flexible platform that can integrate into almost any data center architecture. The notion that NVIDIA is simply building GPUs is a gross oversimplification. They're creating AI factories, massive, intricate systems designed to run AI workloads at an unprecedented scale. And it's about how seamlessly these AI factories fit into existing infrastructures, providing solutions that work for both cloud providers and more specialized industries. Now, let's talk about the real game changer here, Tesla's self-driving technology. Huang doesn't just mention Tesla in passing. He emphasizes the revolutionary nature of their approach to autonomous driving. What makes Tesla stand out is how they're using generative AI to learn from real-world video. Tesla is using an end-to-end generative model that learns by watching video, predicting the next actions, and adapting to the physical world. The implications of this are massive, not just for Tesla, but for the entire automotive industry. In the coming years, we can expect self-driving technology to become the standard, not the exception. And NVIDIA's hardware is at the core of making this a reality. The beauty of this technology lies in its scalability. What Tesla is doing now could eventually be applied to any car manufacturer that wants to integrate AI into their vehicles. The future of driving is AI, and NVIDIA is making sure that it will be both safe and revolutionary. The future of AI is unfolding before our eyes, and NVIDIA is leading the way. The truth is, we're only scratching the surface of what AI can do, and the potential applications are limitless. From healthcare to entertainment, from automotive to finance, AI will touch every industry in profound ways. NVIDIA's continued innovation in AI hardware and software ensures that they will remain at the heart of this transformation. If this breakdown has given you insight into why NVIDIA and its technology are at the center of the AI revolution, feel free to like, share, or drop a comment. We're only just beginning to see the true impact of these technologies, and there's much more to come.
How big a threat does DeepSeek pose to America's tech industry? I mean, it has almost all the features and functions of the programs that we're seeing like OpenAI, but a fraction of the cost. And what is the emergence of DeepSeek, which has even won praise from the U.S. tech industry? What does it say about America's AI tech? Has it been overspending and under-delivering?
It looks like a massive threat. Here is a cost advantage that we haven't seen. It's something we call exponential efficiency. And at 6 million versus hundreds of billions of dollars, it looks like they found a crack into this. But the short answer is it's not that easy to do. And what you're going to see is it doesn't necessarily solve all your problems, but we now know that there's a way to deliver AI at a fraction of the cost and the ability to do that with open source models. And that's what we're all hoping for in the AI world, because unlike the internet, right now AI is closed, it's centralized, it's expensive, and there are few players. And if we were trying to get an internet level explosion, you need decentralized, open, you need cheaper and a lot more players to be able to be in this model. And so what they've shown is that this is possible. But the challenge is AI isn't that easy. And so, yes, you might be able to solve that model in this manner, but it's going to take a while to get the refinements as well. So there's a lot more to do to get to AGI. But this is a very interesting thing in terms of rattling markets by saying, is the US spending too much? Are we spending too much on data? Can we do this with less energy? And that's the right question to ask, because we want to see technology costs come down over time.
In the fast-evolving world of artificial intelligence, the race for supremacy isn't just about who builds the smartest model. It's about who can build it faster, cheaper, and make it truly useful. Recently, a Chinese AI leader, Kai-Fu Lee, dropped a reality check that has sent shockwaves through the tech world. especially for Sam Altman and OpenAI. Kai-Fu Lee is pointing to a strategic leap that challenges everything we thought we knew about how AI companies compete. At the center of this is DeepSeek, an open-source AI model that, according to Lee, is running at a fraction of OpenAI's enormous operating costs and still delivering impressive results. Imagine running a top-tier AI system at just 2% of the cost of your biggest competitor. That's a potential game changer, but it's not just the cost savings that matter. DeepSeek's strength lies in its adaptability, how it can be molded to work seamlessly with real-world business systems like finance, insurance, and customer service. Kai-Fu Lee's company, 01.ai, is building the missing pieces, the middleware and interfaces, that turn DeepSeek from an impressive AI kernel into a practical tool that companies can actually use every day. This is where the real challenge to OpenAI emerges. For all its breakthroughs, OpenAI's model remains costly and resource-intensive. The question Lee raises is clear. Can OpenAI maintain this expensive pace when a competitor offers a similar quality model for free, with the backing and funding to sustain it long-term? This is grounded in the economics and realities of AI development today. The founder behind DeepSeek has the financial stamina to keep this open-source model alive and evolving. Meanwhile, OpenAI is burning billions annually. This financial pressure adds a new layer of complexity to the AI race, beyond the technical prowess of the models themselves. Moreover, the Chinese AI landscape is poised to support just a handful of major players, with DeepSeek currently leading, alongside giants like Alibaba and ByteDance. That means market momentum is crucial, and 01.ai is betting big on DeepSeek's future. The analogy Kai-Fu Lee draws between AI foundational models and operating system kernels is telling. Just as the Windows kernel alone is useless without the software ecosystem that runs on top, the value in AI now lies in those practical layers: the applications, the user interfaces, and integrations that turn raw AI power into real business advantage. Investors see this shift clearly. The days of pouring massive funds into new pioneer models are waning. Instead, capital flows toward AI infrastructure and applications that deliver tangible solutions. One might wonder if US tech sanctions and limited access to advanced chips could slow China's AI advance. But Lee argues the opposite happened. Facing those restrictions forced Chinese developers to innovate smarter and more efficiently, cutting computing costs dramatically and reinforcing their competitive edge. The pace of AI development is blistering, with frequent releases from leading companies. China's strategy of combining open-source models, smart infrastructure, and strong local government support is propelling its AI industry forward at breakneck speed. So, where does that leave OpenAI and Sam Altman? Facing a bold and cost-effective challenger that's not only competing on technology, but rewriting the rules of AI economics and deployment. It's no surprise that this challenge could keep Sam Altman awake at night. This is a glimpse into the future of AI innovation and global competition. Stay tuned as we unpack the full story behind this bold move from China's AI frontier. You don't want to miss what's coming next.
If you think about OpenAI's cost of $7 billion of operating costs in 2024, DeepSeek probably operated with 2% the operating expense. So with that kind of formidable competitor, I think Sam Altman is probably not sleeping well.
Kai-Fu Lee, one of China's top AI leaders, just explained why China's approach to AI could shake up the entire industry. And he did it in a way that left Sam Altman with a lot to think about. In this video, we break down what he said and why it matters.
I mean, it's perfect timing because you've just launched an enterprise large language model that's also going to be deploying DeepSeek more broadly. But talk us through exactly what it entails.
Yeah, well, I think China had its ChatGPT moment when DeepSeek came out. We can call it DeepSeek moment. Everyone's aware of it over the Chinese holidays. Everyone's talking about it, and the CEOs came back to work saying, put DeepSeek to work at my company. And what they found out was DeepSeek is a fantastic model, amazing AI, but it doesn't have the middleware and the user interface that it takes to connect to corporate databases, to build applications, to make it useful for HR, finance, and customer service. purpose. So what 01.ai did was we saw DeepSeek has been making great momentum, and we decided to really bet on DeepSeek and build that missing middleware and UI so that DeepSeek can be made useful in corporations. That's the product we announced this Monday, and we're getting fantastic reception in China and also in Hong Kong.
Tell us more about that launch.
So we launched on Monday, and what we talked about was many of you have DeepSeek now. You love to use it. In fact, one CEO friend of mine asked his employees, "What do you use it for?" And
good question.
And the answer was fortune telling. By the way, that's a great thing to try for you, but it's not very deep into the industry, the company. You know, every company has ERP and the CRM databases. They have employee records. They have their internal information, and they want the model to be more a generalist. They want it to be knowledgeable. Bloomberg would want a finance knowledgeable model. Right, Ping An would want an insurance knowledgeable model. So our job is to really build that layer for that purpose. It's sort of like if I gave you a Windows kernel that is the core operating system, you wouldn't know what to do with it. You need all the Windows layer, the application interfaces, so that the Windows kernel can be useful, and we like to think that 01.ai is providing that layer for DeepSeek, which is the underlying model and technology.
And using DeepSeek as the underlying model, I mean, obviously you could have chosen other models instead, including from the US. What does that tell you about where the competition or I guess the race for supremacy stands between China and the United States right now?
Well, clearly, in both U.S. and China, the pre-training of a giant model has consolidated and is consolidating, and it's become clear that open source will be the winner. There's still many that will not concede. Right, OpenAI, Anthropic, who build their businesses believing they can build a better closed model than everyone else. I think they got shocked when they saw a model as good. They would argue nearly as good, but either way, they're getting it for much, much lower cost. If you think about OpenAI's cost of $7 billion of operating costs in 2024, DeepSeek probably operated with 2% the operating expense. So the issue really isn't whose model is 1% better. I think they're all very good. But the issue is OpenAI's model even sustainable, right? I mean, you're spending $7 billion a year, making a massive loss, and here you have a competitor coming in with an open source model that's for free. And that company also is infinitely lasting because this founder has enough money to fund it at the current level and has reduced the cost of computing by a factor of 5 to 10. So with that kind of formidable competitor, I think Sam Altman is probably not sleeping well.
Kai-Fu Lee just laid out a pretty serious challenge to Sam Altman and OpenAI, and it's one that might keep Sam up at night. He explained that in China, DeepSeek, an open-source AI model, suddenly took off. Everyone was using it, but businesses quickly realized it didn't have the tools to connect with their actual systems, like databases or CRMs. So Kai-Fu Lee's company, 01.ai, stepped in to build those missing parts, the middleware and user interfaces, so DeepSeek could actually be useful in industries like finance, insurance, and customer service. And here's where things get intense. Kai-Fu points out that while OpenAI is spending billions to build and run their models, reportedly $7 billion this year, DeepSeek is running at just 2% of that cost. That's a huge difference. On top of that, it's open source and backed by a founder with the money and efficiency to keep it going long term. He's not saying one model is a little better than the other. He's saying, can OpenAI even keep this up when a serious competitor is giving people similar quality for free?
Yeah, well, you do think, I mean, obviously, that DeepSeek would have really challenged some of the monetization strategies around AI. But at the same time, given that AI is so commoditized now, and in China as well, that open source approach, how many AI models do you think that the Chinese market can actually sustain?
Well, I think probably, I'm guessing 3, DeepSeek, Alibaba, and ByteDance. And they'll evolve over time. right?
Okay, there's a few names missing on that list.
Yeah. Well, there will be many other who aspire to build one,
right?
And we'll see if there's a fourth player. But even within these three, I think DeepSeek currently has the momentum, and that's why we're embracing that. But I also want to point out that I wouldn't say AI is commoditized. I would say the underlying pioneer model, foundation model, that is trained with a huge amount of money is commoditized. It costs a lot and it's hard to really compete with open source. But AI is not commoditized, right? It's like, Windows kernel, Linux kernel, that's kind of commoditized. But Windows is not commoditized. Microsoft makes a ton of money. And what 01.AI wants to do is build Windows and use DeepSeek as our Windows kernel.
And is that where you think the value added comes now? In other words, for VCs thinking about where the value added is in this industry, it's no longer, for example, AI, for example, still presents that value. And I want to understand, for example, the economics and why you think, say, there's only room for 3 as well.
Well, there may be room for 4, but in most markets, you end up with room only for 2. Right? The winner who makes a ton of money, the runner-up who breaks even, and everyone else who dies. And this one is exacerbated because it's hard to monetize the underlying pioneer model. But once you are the winner, there are many ways to monetize it.
Right.
So that's the trick. For the VCs in both US and China are moving away from wanting to fund more pioneer models. They're happy to fund AI infrastructure, AI applications, consumer apps, because every app will be remade, right? And also enterprise apps that can provide real value add to enterprises. So AI funding is going gangbusters. It's just that nobody wants to fund pioneer models.
Does China's innovation, though, come up against the headwind this year of greater restrictions on China's access to advanced semiconductor technology? Is that going to end up presenting a problem?
So we can look at historically, right? China is able to catch up and build great engineering products while US is better at making breakthroughs. That was what I argued in AI Superpowers, and that continued to be the case. The GPU sanctions came 2 years ago. And today, we actually see DeepSeek not only resilient, competitive, but also basically made true the statement that necessity is the mother of innovation. That because they had so few GPUs, they had to make it 10 times more effective. So I think I would argue that the sanctions so far hasn't worked. It's hard to project the future, but I would say that DeepSeek actually benefited from having less resources and able to make training and inference at 5 to 10 times lower the expense incurred by OpenAI and others.
Kai-Fu Lee explained why DeepSeek is gaining real ground in China. He believes the market can likely support 3 main AI models: DeepSeek, Alibaba, and ByteDance. Right now, DeepSeek has the lead, which is why his team at 01.AI is building on top of it. He compared the current stage of AI to early operating systems. The core models might be widely available, but the real value comes from what gets built around them: the user interfaces, the tools, the connections to company systems. That's where companies can create something people actually use. Venture capital is following that shift. Investors are moving away from funding massive foundation models. Instead, they're putting money into infrastructure, apps, and AI tools that solve specific problems for businesses. As for hardware limits from US sanctions, Kai-Fu said the results speak for themselves. DeepSeek became more efficient, cutting training and computing costs by 5 to 10 times.
I remember, so DeepSeek was, what date is it? March 20, so let's call it 2 months ago. I remember we had the chat on the show, I think it was back in October, where you guys actually launched something similar months before DeepSeek. And so you guys came out, DeepSeek came out, and then since DeepSeek came out that moment, just the cadence and the frequency of all these ones coming out with their own iterations of it. I guess my question is, what do you make of the frequency? What is behind, you think, the frequency of these releases? And is DeepSeek the symptom, or is it the cause of what's going on? In other words, what can we expect from the industry this year?
I think it's still ultra competitive. The fact that I think China will have 3 winners, US might have 4 winners at the end, doesn't mean dozens of others will not want to compete. So I do expect frequent releases to continue especially from the fast-moving companies. And I think the fastest moving companies probably are xAI's Grok and DeepSeek. I'd say these are the fastest. And then I think OpenAI, Alibaba, Google, and Anthropic are, of course, all making respectable moves. I listed ByteDance because they're not on the list by people, but we know how much they're spending. And I think one way you can justify spending a ton of money on pioneer models is because you have so many customers that when amortized over many, many customers, you can make the business case. And ByteDance has more customers and more ways to monetize than anybody, so I would make that speculation.
Yeah, I think Baidu is one of the names that sort of stands out to me, not on that list, and maybe you can share some reaction on that, but also government support from Beijing. Exactly how do you see that also shaping up over the coming year?
Well, we all respect and thank Baidu for really starting the transformer revolution in China. They tried to hire Jeff Hinton and ended up hiring Andrew Ng. And I think that shows that Robin has that kind of vision. The execution is currently lagging, and we'll see what happens. And your other question was
government support.
Government support, right? So the Chinese government's new big direction is called new quality productivity. What that means is using high tech to create productivity, efficiency, and really turn all the traditional industries into more profitable, more competitive by the use of high tech, and AI is at the very core of that.
Actually, so our final question for you, because you mentioned the word consumption in AI was actually mentioned in Premier Li Chang's work report from the NPC, and to the point that Mel was making on, government support, it was rare that we saw just the CEOs of China's big tech companies in the same room as the president, for example, weeks before that. And I'm wondering, tangibly, what measures do you think we could see from the government to be able to back up what really seems as very, very good optics?
Yeah, I think right now the local governments probably are the most active in trying to see, I'm city X, I'm the party secretary of mayor of city X, and this city is very strong in the following industries. How would I apply AI to create this new quality productivity in these industries? That will end up helping the growth, the GDP of the city. And I think, having a single direction from the top, new quality productivity is very, very effective and invigorating to the cities. And we're seeing a lot of interest for our company and our peer companies to work more closely with these local cities.
Kai-Fu Lee ended by pointing out how fast the AI race is moving, especially in China. He said companies like DeepSeek, SAIC, and Grok are releasing new models at a rapid pace. In his view, China will probably have 3 leading AI players, while the US may end up with 4. But that doesn't stop dozens of others from trying to compete. He also brought up ByteDance, not often mentioned in AI conversations, but they're spending heavily and have a huge user base. That scale gives them more ways to recover costs and turn AI into a real business, which makes them a serious contender. When asked about government support, Kai-Fu explained that China's new strategy, called New Quality Productivity, is all about using high-tech tools like AI to boost traditional industries. Local governments are already jumping in, asking how AI can improve their region's economy. His company is now working with several cities to help turn that vision into results. So while the global AI race continues, China's approach is picking up speed. And it's not just about building models. It's about turning them into tools that drive real economic change. The global AI race is moving faster than ever, and Kai-Fu Lee made it clear China isn't falling behind. With open source models, smart infrastructure, and strong local support, they're building real momentum.
We have an AI and robotics fund, and we hold probably most of them because they are going to benefit from the declining cost in AI. And even Meta, who was really the open source leader, DeepSeek is open source.
Kathy Wood just dropped a major insight, and honestly, it's hard not to get excited. She says the cost of innovation is collapsing, and she's not exaggerating. According to data from ARK, the cost to train AI models has been falling about 75% per year, and inference, the part where AI is actually used, is getting cheaper by up to 90%. That's a game changer. And here's where it gets interesting. She's saying this shifts the power away from just the chip makers like NVIDIA, which dominates training, and toward companies that actually apply AI in the real world. That includes Palantir, one of ARK's top holdings. With AI becoming more affordable, tools like Palantir's platforms are suddenly way more scalable. What really caught my attention? Her point about healthcare and autonomous mobility. She's saying AI combined with things like gene sequencing and CRISPR could help cure diseases. That's not hype. Companies like Illumina and CRISPR Therapeutics are already showing promising data in this space. And when she mentions DeepSeek, that's serious. China's AI models are catching up fast, but she sees that as a good thing. More competition, lower costs, and more breakthroughs. Honestly, if she's right, we're looking at a wave of innovation that everyone can benefit from, not just the tech giants.
I think what it's telling us is the cost of innovation is collapsing, which it has been doing. I mean, the cost of AI training is dropping before this, 75% per year. The cost for inference, 85 to 90%. I think it throws the weight more towards inference chips from training chips. And so NVIDIA is highly exalted, and deservedly so, in the training chip space. Inference is a lot more competitive.
Okay, do we fully understand the implications of that? Because the question that everybody's asking this morning is, do I buy the dip? So if we're seeing the landscape changing, is it too early to make that transition and understand what the implications of it are?
Yes, we've been studying the tech stack and where we think it's going. We're going to put out big ideas in, I think, a week.
Give us some hints.
Yes, so here's a hint. We do think there are share shifts taking place within the tech stack. We think platform as a service, so think Palantir, is going to gain significant share. And this news yesterday, I think, highlights that, reinforces that. We think infrastructure as a service is going to stabilize the share. Software as a service will come down a share. However, I've said all of that. All of them will be growing rapidly. It's just how rapid. Okay. It's going to be extremely positive. So those using AI, whether for productivity or other applications, are going to benefit. We think the two most profound use cases right now, besides increasing productivity for everyone, autonomous mobility, so think cars, drones, and so forth. And interestingly, the healthcare space. We think the convergence of various sequencing technologies, AI, and CRISPR gene editing, that convergence is going to cure more and more diseases over time. Competition is great for the U.S., and DeepSeek is competition, no doubt about it. I'm hearing all of the titans, tech titans, speak of it glowingly. I don't think we know everything about it yet. So, no, I think it's competition is good for the United States. Lowering costs is great for the world. The collapse in the cost of innovation should help all regions of the world. I will say that new productive forces, which was Xi Jinping's new phrase, I think 18 months ago, seems to be showing through right now. Common prosperity was the previous one, and I still think that's in effect. That was more about margins. This is about innovation. So we're looking more closely at China now.
I want to pick up on China in just a moment, but I want to go back to that point you make about cost of innovation collapsing specifically. That would almost lead to the fact that perhaps it brings down the barriers of entry for mid-cap tech firms or maybe people away from the hyperscalers. But you haven't seen that second level outside of the AI adopters really catch the same bid in the way you see Amazon or Microsoft or even Oracle catch up a little bit. What's the hiccup there if, as you say, the cost of innovation is collapsing? Why aren't some of these stocks reflecting that?
Well, I think there's a big debate going on. And if you look at the second, third, and fourth quarter of last year, you look at the mega caps and the rest of the stocks in the S&P 500, you'll see mega caps in the second and the fourth did very well, and the smaller cap stocks did very well, much better than the mega caps in the third quarter. I think there's a little bit of a tug of war evolving here, and if we're right, the most massive concentration in the market in history, worse than the Depression, is probably going to give way to a broader based bull market. We're seeing that in our portfolios, and it really did start right around actually the day after the election. And I think one of the most important things is going to happen is regulations coming down. Even in AI, in the United States, their regulations started to intrude in a technology that is today where the internet was in the early 90s. We don't even know what we have yet. We're as excited as back then, but now is not the time to regulate it heavily.
Okay, this next part from Kathy is honestly eye-opening. She talks about hyperscalers, big names like NVIDIA, Microsoft, Google, and why she's not just going all in on them. Yeah, they're important. Meta and Amazon are in her portfolios. But here's the thing. She believes the market is way too focused on just a few giants. And she's got a point. Right now, the top 7 tech stocks make up nearly 30% of the S&P 500. That's the highest level of concentration since before the Great Depression. And Kathy warns that's not healthy. Real bull markets are broad, not built on 6 or 7 stocks carrying everything. Then she drops a bomb. DeepSeek reportedly trained its model for only $6 million. That's mind-blowing. OpenAI's GPT-4 was estimated to cost over $100 million to train. If DeepSeek really pulled that off, it proves that you don't need trillions of dollars to be a major AI player anymore. That opens the door for smaller, more agile companies to compete. It's not just a rich man's game anymore. She even compares the current moment to Nixon visiting China, a historic shift. She thinks even someone like Trump could back innovation coming from China if it forces America to push harder. And that's a wild but interesting take. Global competition might actually reignite American innovation. And then she gets real about the risk of market concentration. During the Depression, once that bubble burst, smaller companies exploded in performance because they'd been crushed for years. She thinks we might be at that same turning point right now, where smaller, overlooked companies start to lead as fear gives way to opportunity.
If you're following Elon's moves and how government policies impact the markets, you need Seeking Alpha. It's my go-to for expert stock analysis to help you stay ahead. Check the link in the description for a special offer. Our channel may earn a commission.
Do you think, well, we do own Meta and Amazon in our flagship, and we own more of them in our other more specialized portfolios. And in Europe here, we have an AI and robotics fund, and we hold probably most of them because they are going to benefit from the declining cost in AI. And even Meta, who was really the open source leader, DeepSeek is open source. I think Meta is saying, wait a minute, what's going on here? And they're going to use some of the techniques, the algorithms that DeepSeek has used to improve their own platform. So we're not negative on them. We think that the neglect of the rest of the market has been extreme, and that is going to change. That the strongest bull market out there is a broad-based one. A market favoring 6 or 7 stocks alone is not a strong bull market. And so if we're right, the bull market will strengthen out and gain momentum, rewarding smaller cap stocks than we have seen thus far? Well, I think DeepSeek just taught us that the answer is less than people thought. You don't need as much cash as we once thought. I don't know if the number is right, 6 million to train that model. That's unbelievable. It's a tenth or less. Now, many people don't believe that, but again, it fits in with the costs collapsing thesis. They were collapsing anyway. DeepSeek has just stepped it up a notch. It's very interesting. We've been thinking about President Trump, or many people have been thinking that, oh, wow, this is very negative for China and U.S. Relationship with China. But there is another point in history that might be repeating to some extent here. It's called Nixon in China. Nixon did not trust China. He and everybody trusted Nixon because he did not trust China, and they knew he wouldn't lead us astray. I think the same thing is happening here with President Trump. And from a technology point of view, I think he likes the competition, and he actually did say, I believe yesterday, that, this just shows that even in the U.S., regulations, especially that executive order on AI, which he rescinded, probably has held us back. And now, let's go. If you look back at the Depression, I'm not going to get all of these numbers right. What you'll see is the massive concentration took place until 1932. Yeah. At which point, the market started broadening out. And small or mid-cap stocks back then way outperformed large cap stocks. And it makes sense. They had been absolutely destroyed during the Depression, which was binary. Is this company going to survive or not? With output down 30%, GDP down 30%. It is surprising to me that we got to an even greater point of concentration than the Great Depression. It tells you that in an underlying sense, there was a lot of fear in the market, and that investors were piling into cash-rich companies that, oh, by the way, had, a leg up perhaps in this new thing called AI. Now I think it's just going to broaden out.
We're looking at a Bitcoin handle of about 103,000. Kathy, I want to bring you into this conversation. You've been a crypto bull for a very long time.
Yes.
You've also, prior to the break, talked a lot about deregulation under Donald Trump in the tech sector, but then also in the crypto sector as well. What has fundamentally changed since he's taken office when it comes to deregulation?
I think we will get significant clarity in terms of regulation. We will get legislation as well. I think many more policymakers in Washington understand that this was a single vote issue for many voters, especially young voters. And so this is becoming much more of a bipartisan issue. And of course, you have the executive branch also supporting it mightily, proposing that we include Bitcoin in Treasury reserve. So you've got, I think we're going to have support of all three branches of government are going to be supportive, which is a big change.
Well, it would be a big change. And I mean, are we really sure of that, I suppose, is the question, because Gary Gensler, the SEC, had a very different view of the risks and the retail investor protections that should be in place when it comes to crypto. There are surely a lot of people who still believe that's important.
Well, I think he didn't understand that this is the next big wave of the internet. This is the layer of the internet that developers did not build in the early 90s because no one thought anyone would buy or use financial services on the internet. I remember back then, no one was going to give their credit card to the internet, right? This is the next big wave, and it's a huge efficiency move for the financial services sector. So in terms of Bitcoin specifically, it is really the leader in a new asset class. And we have a paper out on that. You can see the low correlations, which do define a new asset class. And it is a global monetary system. It's a very big idea.
And just when you thought Kathy was done making waves, she drops a Bitcoin prediction of $103,000. Yeah, you heard that right. Kathy's been a longtime crypto believer, but now she's saying the regulatory environment is finally catching up. She's convinced that with Trump back in the mix, and a growing number of young voters making crypto a single-issue priority, we're heading toward full legislative support. That includes Congress, the courts, and even the executive branch backing Bitcoin. One proposal even suggests including Bitcoin in the US Treasury Reserve, which, if it happens, would be massive. Now, some people are still cautious, especially after years of SEC pushback from Gary Gensler. But Kathy says Gensler missed the big picture. Crypto is the financial layer of the internet. Back in the 90s, no one trusted the internet with their credit card. Today, we barely think twice. Bitcoin, in her view, is that next leap. A global, decentralized, rules-based monetary system. Kathy worked with Art Laffer, yes, that Art Laffer, to show Bitcoin's low correlation to traditional assets. Statistically, it behaves like a new asset class. It's not just tied to tech stocks. During the regional banking crisis in 2023, while banks collapsed, Bitcoin soared. That's because it has no counterparty risk, no middlemen, no bank failures, just a scarce, decentralized system with 21 million coins, ever. As for stablecoins, she sees them complementing, not replacing, the US dollar. They're backed by US treasuries anyway, but central bank digital currencies, she's not buying in. States like Florida and Texas are already rejecting them over privacy concerns, and she says privacy must be protected, and she believes the president agrees. Of course, she's cautious too. She remembers the ICO bubble of 2017, when Bitcoin hit $20,000 and most other tokens failed. It's why she supports smart regulation, not to kill crypto, but to protect people from the scams that keep popping up. So if Kathy's right, we're heading toward a future where Bitcoin is a mainstream asset, stablecoins back real-world finance, and regulation helps, not hurts, the next wave of internet innovation. So with Bitcoin gaining momentum, AI costs crashing, and market dynamics shifting fast, Kathy's message is clear. The next wave of innovation is already here. The only question now is, are we ready for it? China just shocked the AI world, and OpenAI is feeling the heat. A new model called DeepSeek is making waves, and it's not just powerful. It's cheap, fast, and catching up fast. Here's why OpenAI is worried, and why this changes everything.
China's latest AI breakthrough has leapfrogged the world.
I think we should take the development out of China very, very seriously.
A game-changing move that does not come from OpenAI, Google, or Meta.
There is a new model that has all of the valley buzzing.
But from a Chinese lab called DeepSeek.
It's opened a lot of eyes of what is actually happening in AI in China.
What took Google and OpenAI years and hundreds of millions of dollars to build, DeepSeek says took it just 2 months and less than $6 million.
They have the best open source model, and all the American developers are building on that.
I'm Deirdre Bosa with the Tech Check Take, China's AI breakthrough. It was a technological leap that shocked Silicon Valley. A newly unveiled, free, open source AI model that beat some of the most powerful ones on the market. But it wasn't a new launch from OpenAI or model announcement from Anthropic. This one was built in the East by a Chinese research lab called DeepSeek. And the details behind its development stunned top AI researchers here in the US. First, the cost. The AI lab reportedly spent just $5.6 million to build DeepSeek version 3. Compare that to OpenAI, which is spending $5 billion a year. And Google, which expects capital expenditures in 2024 to soar to over $50 billion. And then there's Microsoft, that shelled out more than $13 billion just to invest in OpenAI. But even more stunning, how DeepSeek's scrappier model was able to outperform the lavishly funded American ones.
To see the DeepSeek new model, it's super impressive in terms of both how they have really effectively done an open source model that does what is this inference time compute, and it's super compute efficient.
It beat Meta's Llama, OpenAI's GPT-4o, and Anthropic's Claude Sonnet 3.5 on accuracy on wide-ranging tests, a subset of 500 math problems, an AI math evaluation, coding competitions, and a test of spotting and fixing bugs in code. quickly following that up with a new reasoning model called R1, which just as easily outperformed OpenAI's cutting-edge O1 in some of those third-party tests.
Today, we released Humanity's Last Exam, which is a new evaluation or benchmark of AI models that we produced by getting, math, physics, biology, chemistry professors to provide the hardest questions they could possibly imagine. DeepSeek, which is the leading Chinese AI lab, their model is actually the top performing, or roughly on par with the best American models.
They accomplished all that despite the strict semiconductor restrictions that the US government has imposed on China, which has essentially shackled them out of computing power. Washington has drawn a hard line against China in the AI race, cutting the country off from receiving America's most powerful chips like NVIDIA's H100 GPUs. Those were once thought to be essential to building a competitive AI model, with startups and big tech firms alike scrambling to get their hands on any available. But DeepSeek turned that on its head, sidestepping the rules by using NVIDIA's less performant H800s to build the latest model and showing that the chip export controls were not the chokehold DC intended.
They were able to take whatever hardware they were trained on, but use it way more efficient.
But just who's behind DeepSeek anyway? Despite its breakthrough, very, very little is known about its lab and its founder, Liang Wenfeng. According to Chinese media reports, DeepSeek was born out of a Chinese hedge fund called High Flyer Quant that manages about $8 billion in assets. The mission on its developer site, it reads simply, unravel the mystery of AGI with curiosity. Answer the essential question with long-termism. The leading American AI startups, meanwhile, OpenAI and Anthropic, they have detailed charters and constitutions that lay out their principles and their founding missions, lengthy sections on AI safety and responsibility. Despite several attempts to reach someone at DeepSeek, we never got a response.
How did they actually assemble this talent? How did they assemble all the hardware? How did they assemble the data to do all this? We don't know. And it's never been publicized, and hopefully we can learn that.
But the mystery brings into sharp relief just how urgent and complex the AI face-off against China has become. Because it's not just DeepSeek. Other more well-known Chinese AI models have carved out positions in the race with limited resources as well. Kai-Fu Lee, he's one of the leading AI researchers in China, formerly leading Google's operations there. Now his startup, 01.ai, it's attracting attention, becoming a unicorn just 8 months after founding and bringing in almost $14 million in revenue in 2024.
You can feel the tension at OpenAI right now, because China's AI game just leveled up fast, and nobody saw it coming. A Chinese lab called DeepSeek dropped an open source model that beats GPT-4, Claude, and Llama in coding, math, and reasoning tests. That's already wild. But here's what really shocked people. They built it in just 2 months for $5.6 million. Meanwhile, OpenAI is spending $5 billion a year, and Google is about to drop $50 billion on AI infrastructure this year alone. It's not just the cost, it's how they did it. The US tried to slow China down by cutting off access to NVIDIA's best chips, but DeepSeek said, okay, and used lower-tier H800s, trained smarter, and still built a model that competes at the top. Even more unsettling, no one really knows who's behind DeepSeek. There's no clear safety charter, no transparency, and barely any public communication. Compare that to OpenAI and Anthropic, who constantly talk about alignment and AI ethics.
The thing that shocks my friends in the Silicon Valley is not just our performance, but that we train the model with only $3 million. And GPT-4 was trained by 80 to 100 million.
Trained with just $3 million. Alibaba's QN, meanwhile, cut costs by as much as 85% on its large language models in a bid to attract more developers and signaling that the race is on.
If you found this breakdown helpful, make sure to like the video and subscribe for more deep dives like this.